Okay, we're going to do a couple more of these variation problems. So this is another example of direct variation. In this problem, so problem E, it says the pressure exerted by a certain liquid at a given point varies directly as the depth of the point beneath the surface of the liquid. Okay, so how about the pressure varies directly as the depth of the point, let's just call that the depth. So as we put this together, so this is E, so we know that the pressure varies directly as, so equals some K times, so that's the vary directly as, it's K times something, the depth. Okay, and then from the last video, we saw that the first step was to find K. So I'm going to look for some information where I'm given a pressure and a depth that go together. Well, we keep reading. It says the pressure at 50 feet. So as I put this together, the pressure at 50 feet, that's a depth, is 400 pounds per square inch. So that's a pressure. So 400. To solve for K, we're going to divide both sides by 50. And K is 8. And there's no unit here because it's just this multiplier. Step number 2. So step number 2 is to use K to answer the question. So as I go back up to my formula that I started here, I have now some more information. So I know that pressure varies directly, so pressure equals K times, but we found that K was 8, so it equals 8 times the depth. Okay, where was that question? Let me scroll down for a second. The question says, what is the pressure? So that's going to be my variable. What's the pressure at 20 feet? 20 feet is my depth. Pressure is my variable. So what is the pressure? Oh, let me go a little bit further. At 20 feet. 20 feet is my depth. Okay, so all I need to do is multiply. 8 times 20 is 160. And if you read the question, the units for pressure was pounds per square inch, but you can probably just type in the 160. Okay, so 160. One last question. The last question is F. This one has slightly different language. It says varies jointly. That means we're going to have two variables on the side that's multiplied by K. So this one says that the weight of a fish, so if we set up F, it says the weight of a fish, so weight varies jointly as equals K times, but jointly means I'm expecting two things now on the other side of the equation. As its girth, which is sort of like a width, I don't really know, I guess. So as its girth, and the square of its length. And for and, we're really multiplying the square of its length. Okay, so I'm just going to write length to the second power. So that's the formula that we're working off of. Step number 1, find K. So I've got to find enough related information that gives me a weight and the girth and length of that fish. Okay, one fish weighed 24.3 pounds. 24.3 equals K times. Measured 37 inches long, that's the length, so it's going to be 37 squared with a 26-inch girth. 26-inch girth. Okay, so I've got to go ahead and multiply some things together here. So on the right-hand side, I need 26 times 37 squared. So this number right here becomes 35594. 35594. Just multiplied these out on my calculator. I have 24.3 on the other side of the equation. I'm going to divide both sides by 35594 to solve for K. 35594. So 24.3 divided by 35594. And my calculator gives me, here I'll show you, it gives me this. It gives me this E notation. This is scientific notation. It's giving me 6.827. I'll keep those many decimal places. E, which is times 10 to the negative fourth. So here's what my calculator gives me, which is not correct notation for writing down on your paper. Wait, I missed a digit. 6. 826, and then I have a couple of 9s here. I'll do that much. Okay, 6.82699 e negative 4. But this was really scientific notation. It means 6.82699 times 10 to the negative 4. That negative 4 tells me that there are 4 decimal places between 0 and the decimal place right there. So 4 decimal places. 1, 2, 3, 4. That's going to be the 6. 8, 2, 6, 9, 9. And I can put a little approximate symbol there if I want to. Okay, so now I've got it. Step number 2. Use K to find the missing information. So weight is equal to K, 0.00068. Let's call that 6827 times the girth times the length squared. Length squared. Back in my problem, it says how much would a fish 41 inches long? So that's going to be the length. So 41 squared with a 25-inch girth, 25 weigh 0.00687 weigh. That's the